again to Discovery Lab Live here at the Wall Family Discovery Lab in the Rory Myers Children's Adventure Garden at the Dallas Arboretum. My name is JC and I'm the Public Programs Manager here. And today we are going to be doing an awesome experiment called Catalyst Catastrophe. Now, catalyst, that sounds like a big science word. Do you know what catalyst means? I bet we can figure it out today. Let's start by talking about chemistry. Chemistry is a field of science where we study different chemicals or substances that make up everything around us. Today, we're going to start by looking at this paper bag. Now, if I wanted to change this paper bag, what could I do to it? Maybe I could decorate it, or blow it up and puff it up, or maybe I can just crush it up. So I'm going to crush it up right here. I changed it, didn't I? But I have a question. Did I change what this is made of? I think it's still paper. So what I did here was a physical change. I changed the physical nature of what I was working with, but I didn't change its chemical structure or the substances that it's made of. However, if I was to take this paper and dissolve it down into another chemical and mix them together so that they combined into something new, that would be a chemical change. So today, let's take a look at a chemical change you can try at home. We're going to be using a few different materials today. This right here is called hydrogen peroxide. You may have used it before to help clean any cuts or sores that you have. Hydrogen peroxide is made of two different atoms, hydrogen and oxygen, also known as H2O2. Sorry. So this has two oxygen molecules and two hydrogen molecules. Let's switch over to my close-up camera so you can see just how cool. I have two different models of them today. All right. Miss Blanca, do we have our camera switched over? Awesome. So this is our first molecule of H2O2 or hydrogen peroxide. This is another one. Now, when these two just sit here over time, eventually they will begin to break apart and come apart just like that. These toothpicks represent bonds that hold the different atoms together. Now, if these break apart over time, they'll actually separate into something new. So I'm going to take apart this one oxygen here, and we're left with H2O. That sounds like something I've maybe heard of before. Do you know what H2O is? Now, if I take the other molecule and separate it apart as well, then I've got now two molecules of H2O, and I've got one molecule of O2, or oxygen. Now, this is a pretty cool thing that happens. If you notice, the hydrogen peroxide bottle is a dark color. That's because light causes the hydrogen peroxide to break down like this into different materials. But we can actually make that reaction happen a lot faster by using a catalyst. Now, do you remember the name of our program today? Catalyst Catastrophe. A catalyst is anything that speeds up a chemical reaction and is not affected itself. Our catalyst today is going to be yeast. Ooh. Now, you may have seen yeast before used as something to help with baking. yeast eat sugars and then make little toots to make your bread rise and be nice and fluffy. So we're going to take some of our yeast today and use it as a catalyst to help break apart our hydrogen peroxide. So in order to do this, we need to get the yeast to wake up and get activated. I'm going to take just a small amount of the yeast, 1 teaspoon. This right here is the teaspoon I'll be using today. So if you've got your yeast, go ahead and grab a teaspoon. Now you want to make sure that your teaspoon is level across the top. It might get a little messy, but that's okay. So I'm going to take my yeast and I'm going to put it into my cup here. Very good. Now, in order to get the yeast active, I'm going to have to add warm water to this. So I'm going to use my measuring tool and I'm going to add some yeast. I'm going to add, let's see here. Whoops. I'm using a different container today, so I have to make sure that I change up my amounts that I'm using. So it looks like today I'm going to be adding just enough water to cover the top of my yeast for right now. I already started getting my water warm back behind me, so I'm going to grab that water now. All right, so I've got my yeast here, and I've got a little stir stick, or you can use your finger. And I'm just going to stir that yeast around until it's mixed in really well. If you remember one of the other weeks, we talked about mixtures and solutions. Which do you think this is? A mixture or a solution? All right, so it looks like my yeast is all mixed in and it's getting ready for a big reaction. All right. The next thing that I want to do is begin to add some of my other materials. While I'm gathering them, what I'd like you to do is take your cup of yeast and smell it. Now in science, we don't want to stick our nose into the containers we're using. Instead, we want to use a technique called wafting. So you're going to take your hand right here and gently fan the smell up towards your nose. And see, what do you think this yeast smells like? It kind of smells like bread to me.
We have a response from Stephanie.
Ooh, Stephanie.
She's asking if it's a solution.
Ah, a solution, yes. So a solution is when we take one material like yeast and we mix it into a solvent like water. So have you ever had to take salt or sugar and dissolve it into water? That would be a solution. Awesome question, Stephanie. Thank you for asking. So you have 1 cup prepared here with your solution of the yeast and water. I'm going to be using a graduated cylinder today to help me out with my reaction. However, you can use a cup just like this, or maybe even a tall, skinny cup if you have that at home. I'm going to take my hydrogen peroxide here, and very carefully, I'm going to put 2 tablespoons. So if you notice, the tablespoon is a little bit bigger than the teaspoon we were using earlier. I'm going to put 2 tablespoons of my hydrogen peroxide into my second container. So if you have a second cup, you'll be using that today, and I will be using my graduated cylinder. So there's 1 tablespoon, and here's my second tablespoon. All right. So I've got my 2 tablespoons of hydrogen peroxide, and now I'm going to add to the hydrogen peroxide a little bit of dish soap. All right, so I'm going to take my dish soap here and I'm going to put a squirt in. If you would like to be more precise, you can add about a tablespoon at the most, maybe just a teaspoon. So I'm just going to put a little squirt in there. All right, so there's my dish soap mixed in. And for fun, I'm also going to add a little bit of food coloring. Yes.
Stephanie has another question.
All right, Stephanie, what's your question?
Coleman wants to know.
Coleman, you know this experiment, don't you? Yes, sometimes we do call this experiment elephant toothpaste. Now, those of you who haven't done this experiment before, you may be wondering, why would this be called elephant toothpaste? In just a minute, you're going to very quickly see why. So I've got my liquids here. This is my mixture of hydrogen peroxide, dish soap, and food coloring. And this is my mixture of yeast and water. I'm going to give that one more stir here. And then we're going to mix these two things together. Now, I'd like to switch back over to my big camera so that way everybody can see this experiment really well. My camera's Miss Blanca to help out with the camera right here. All right, friends. All right. So, I've got my graduated cylinder. I've got my solution of water and yeast. Now we're going to see what happens. You may notice I'm wearing my handy dandy lab coat today because I want to make sure none of these chemicals get on my skin here. I'm also wearing a face shield today, which is to help protect me right now, but I would also normally wear goggles if I wasn't wearing a face shield. All right, friends, are you ready to try the experiment? Let's count it down from 3, 2, 1. Whoa! This is so cool! Wow! It's foaming over. Have you ever heard the word foam before? It looks kind of frothy or bubbly or soapy. Well, that's because foam is just lots of little bubbles that are all connected together. In this case, all of those little bubbles are actually oxygen. If you remember, we said that hydrogen peroxide is made of H2O2, or 2 hydrogens and 1 oxygen. When it breaks down over time, it creates H2O, which is water, and O2, which is oxygen. So when we added the catalyst, the yeast, it made the hydrogen peroxide break down faster. Remember, catalysts help reactions move faster. So the catalyst, the yeast, helped make lots of oxygen that could be trapped in the bubbles and extra water to help make the bubbles outside. Do you like to blow bubbles? I do too. And we just made a ton of them today using chemistry. How cool is that? All right, friends, I hope that you've had fun today learning all about chemical reactions and catalysts. This is a super fun experiment to try at home. So if you're watching now or if you're watching on the replay, there's one last thing I'd like you to do. Check and hold your hand next to the foam and next to your glass. If it's not too warm, go ahead and gently touch it and feel. Mine feels a little bit warmer than when I originally put everything together. I wonder why that may be. I think it's because sometimes in chemistry, heat can get released from reactions, calling it an exothermic reaction, because heat is produced. How cool is that? Well, thank you so much, friends, for joining me today for the Discovery Lab Live. Join us next week where we are going to be building balancing birds. Be sure to check the Arboretum's Facebook page for next week's materials and sign up online at dallasarboretum.org for the Rory Myers Children's Adventure Garden weekly email. Also, don't forget, we reopened for the public on Saturday, February 20th with the Blooms and Butterflies Family STEM Fair. So I hope you had a wonderful time today, and you'll join us next week on Tuesday at 4 p.m. for the next Discovery Lab Live. I'm JC, and have a great day. Bye-bye, everyone.
End screen? Fun.